Thank you, Yasin. On the today webinar, I'm going to present how with GraphDB 3.9.4 and its new mapping interface, you can map strings to things and do faster knowledge graph generation. So the outline is pretty straightforward today. I'm going to give you some introduction about how we see semantic technology, the added value. Then I'm going to give you one fictional use case which describes the typical challenges in building a knowledge graph. And then we'll try to solve these challenges by using the GraphDB 9.4 mapping user interface. So who are we? Ontotext is really one of the pioneers of semantic technology. We are working for more than 20 years in this domain. The company is part of Silver Group, which is traded on the Bulgarian Stock Exchange. We have about 70 people in our R&D center in Sofia, in Bulgaria. And in the last 20 years, we are really seeking how to improve the semantic technology and really make this as a more pleasant experience. Our business is organized in several verticals. We have the GraphDB products and solution teams who deliver also end-to-end type solutions. We are proactively collaborating with the community and all types of industry bodies and standards groups, and we are really proactively participating onto also in some research projects. So that's everything about the company. I will not bother you. And probably one of the core questions which I'm often asked is, what's the added value of the semantic technology? And this is our perception that the RDF is really all about semantics. And semantics is really to how different people and computers understand about models by using shared schemas, which are identified by IRIs. And in these schemas, we have consistent identifiers for the class names, properties, and instances. If you see the picture on the right side, you see one Scots ontology. And I believe pretty much everybody who is on this call probably knows this. And it appears as a simple picture, but as we know what is really Scots preferred label, that this is a unique label which is used as the primary way to identify a concept. We know what is economic cooperation and the concept which is referring it, that this is a thing and it's the preferred way to label it is the economic cooperation. Then there are different alternative labels which are the valid ways to also spell this type of a term. And there are some broader and narrower concepts which further expand and give you this type of a background information. So this is only possible if you use semantic technology. There is no other format which gives you so much with so less type of typing. The only reason is that the people has agreed what is the schema of this model and how to interpret it correctly. And also this schema is part of the model, so you can transfer it so different reasoners can interpret it in the same way as the human. Still, this looks really nice to have task, but it has many challenges. And as you have seen on the previous slide, finding the correct identifiers is really a problem. Basically, it's not easy to remember for the human what is broader and to get all these type of namespaces. And even if there are some shorthand spaces which simplify this process, you never really remember whether this particular predicate was part of SCOS or the SCOS extended model. So you need really some sort of a tooling to quickly navigate through these identifiers and not mistake them. Also, choosing the right really meaning is not an easy task. For instance, even a relatively simple ontology like Dublin Core lists not less than 55 predicates. And if we go to more complex models like FIBO of DBpedia, there are thousands and thousands of classes and properties. And navigating which is the right one and to use it consistently, it could be a pretty challenging task. Also, even if you find them, there is really slight variance, as we saw in the previous slide, like what is the difference between the DC source and DC provenance. You need to open the schema or to be a subject matter expert and to know when to choose one or the other predicate. Another very common task typically, which I face it with some hardcore Python developers or people who are writing scripts to generate RDF, is that it's very easy to generate syntactically correct IRIs. And yeah, they use it everywhere in their code. And even as a human, you see them and they look exactly the same. But if you see these 4 examples, the person will implicitly infer that this is one and the same thing, but this will not happen with the computer. So the computer will find them as their 4 different identifiers, which will cause most likely your graph to not be fully connected and to get what we call dangling identifiers. So this was really the short introduction about the semantic technology, the promise and the challenges. And now let's go a bit deeper in the knowledge graph building process and how easy it is to make one such model. So the knowledge graph building process, like every research project, usually starts with a common research. And for the common research, you start with the encyclopedical knowledge, like you go to Wikipedia, DBpedia, Wikidata, whatever is really the source. You find some public source. And typically these sources have an excellent coverage of the common entities. Like if you are going to find that Europe is a continent, all the countries there, some famous people, how they're connected, and it's an excellent starting point. But once you get and dig deeper in the domain, you are going to see that there are many gaps. And this is really something what we are going to experiment for this webinar to see what are the challenges and how it works. So the typical task once you start from the public sources and you face the harsh reality offered by the subject matter experts who are really experts in any particular domain is that they really say, okay, it's nice to have public knowledge, but we want to integrate our private data or commercial data sources, which usually have a much higher data quality, and they're also much more focused. And sadly, in these commercial sources, there is really no common knowledge about locations, cities, who are the popular people, and some metadata about the organizations because they are strictly focused. And now the very natural question is, how easy is to take the public domain knowledge and easily integrate it with the commercial and the private data, so we can really enrich these, and also with some data from news and social media to enrich this type of information and make one consistent knowledge graph. This is probably one of the most common challenges we are facing once we really want to deliver a commercial knowledge graph project. So in order to make everything a bit more clear with examples, I'm going to take one fictional case. This is a fictional case which is probably quite popular now. This is around the financial crime enforcement network. You remember this FinCEN leak, which was very recent. And the idea is that in this there are some documents about suspicious transactions. So let's imagine that the Federal Reserve, who is in charge of controlling this, they want to build a knowledge graph collecting all data about public US banks, because they're really the regulator and they need to know everything about the US banks. So the general challenge here is how you can take the public and their private information, make it in one knowledge graph, and later on use it for content analytics, tagging, and whatever is really, and the rest of the Ontotext technology stack. So what is really the typical approach and the difference between the subject matter expert and the encyclopedic knowledge, as we stated earlier? The very natural thing is we are going to one of our services, which is hosting a collection of Wikidata and DBpedia, and we are going to ask, tell me what is the full number of the banks which are located in US. And you see that this type of a Sparkle query on the left looks reasonably simple to write. And you get this type of results. In order to make this a bit more interactive, I'm going just to go to this type of a service and see the results. I'm going to execute it once again, and you see that it's really less than 1 second and you get access to this data. There are a few things to note here, that the query looks much simpler, but in reality there are some duplicated things about cities and city labels, and in order to not make multiplications, we just take the first city and the first city label. So let's see the 123 banks which, according to the DBpedia, are known, what we know about them. So we take the first one, which is Moody's Analytics. Okay, it looks like a financial service, and it's located in New York State. There is something that's strange about the location city, that 7 World Trade Center is located here. Probably this is a mistake, but okay, it's quite understandable because these are really public data. And if you scroll down, all these things, I'm not sure what they are, but they look as legitimate banks to me, and I take it as a given. Okay, there are 123 banks. Probably this is the right way, and this is my starting point if I'm a domain subject matter expert. If I'm really working with popular knowledge, I know, okay, there are 123 banks, and that is it. Now let's go to the subject matter expert who is deeply working in this domain and knows have profound knowledge. So the very first thing they will tell you, okay, you have to go to one of these type of registries, and in this case, this is the Federal Reserve, who is going to give you as open data the information which is really there. So we have the list of all the national banks active as the 31st of August here, and we see that the file has a slightly different type of information there. So let me open this type of a file here, and this is according to the registry, the Federal Registry, what we have as a banks. They give it as an Excel file and a CSV, which can be further used. Okay. So moving back to the slides, the very first thing which appears here is that I take one arbitrary bank like Academy Bank, which is a national association, is that there is no Wikipedia article or no item in Wikidata or DBpedia. Okay, it might be hard to believe, but there seems to be many banks which does not exist in Wikidata and the public sources. And the other thing what we know, because we are experts in this domain, is that this is a national association bank. Okay, according to US legislation, there are many different types of banks. One are state member banks, other credit unions, third are federal saving associations, and all of them are really banks. And this type of types are not available in DBpedia or any of the public sources. So I really want to include this type of information because this is the central topic of my knowledge graph, and I want to be very punctual and precise here. Let's take another example. What is the American Bank? It's also a national association. It's also missing from Wikipedia. But the question is really, is this a single bank, or these are 4 different banks? And it seems that in order something to be called a bank, you need to have this type of RSSD ID unique number, which is used by the Federal Reserve to track the different banks. So I will not go deep here, but this seems like 4 different banks, although they share one and the same name because they have 4 different RSSD numbers. Okay, so we saw the complexity between the public encyclopedical knowledge and really the focused private. In this case, this is public data, but really the focused sources and what is really the gap. So now the challenge and the question is it possible somehow to integrate all the data which is from the public domain with the private knowledge, and how GraphDB can help me? So we are going to switch now to the GraphDB mapping user interface, and I'm going to show how we can take this type of a file, which is coming as a CSV file, and later on integrate it in GraphDB and produce a quality RDF out of it. Before to dig in, I would say that the process has multiple options, and today we are going to demonstrate how we start from the structure file, load it in the OpenRefine model. We're going to do some data cleaning because, as you are going to see, even the data offered by the US government is not of high quality, and there are some small glitches in the data which needs to be fixed. This is always if you get any type of CSV or external data. This is the data wrangling problem. And then we are going to show the reconciliations phase, which is basically pointing to an external service and trying to guess from this string what is the knowledge graph entity, the thing which we want to use further on. So we don't want to use strings to work, but to have an IRI which is consistent with the rest of the model. Once we create and clean up this data, we want to generate an RDF mapping. This RDF mapping allows you to download it as an RDF file, or later on export it in order to batch process this type of information and translate and automate it for the future. Okay, so now I'm closing the slides and I'm moving to just switch off my Slack and any distractions. So I'm going to, this is really the GraphDB free 9.4, the latest edition. As you all know, this is the standard layout of the directory. So I'm going to come here and I'm going to just start GraphDB. GraphDB will start up on the local host port 7200, and we are going to start working on the RTFization of this CSV file provided by the National Reserve. Okay, so I'm loading the data. We have an empty vanilla GraphDB instance. The first thing what I have to do is I'm going to create an ontology, a repository. Let's call this Fibo, this model Fibo, because I'll be using the Fibo ontology to describe all specific entities, and for the rest, I'm going to use a schema mix between DBpedia and Wikidata, which are the public sources. So we're creating the Fibo, and here, in order to assist the process, I'm going to load the model and the data here. We have GraphDB will recognize everything what is in your import directory. This is a local directory which you can see here. It's basically your home directory, GraphDB import. I'm going to close this, and you can import all the schemas into the database. So the interface gives you a way how to import them. I'm going to import this, and in this case, I want to load this to a target graph in order to be easier to update it. So I'm going to say, okay, this is HTTP dbp.org. And in the future, if I want to update the schema, I can replace the data. And so this is a very neat feature which uses internal algorithm which optimize the update, so you don't have to really to care and to generate any deltas. I'm starting the update of the DBpedia. So this is a single file, it should be naturally very quickly imported, and the rest are really the Fibo files. I didn't bother to change anything. This is really the direct what you can, the direct zip you can download from the Fibo website. There are XMLs, whatever you have really there. So I'm just going to hope that GraphDB is going to say, I'm going to say this to the Fibo graph, and I'm going to import it. GraphDB is going to skip all the files which are not valid. So for instance, in this case, the XML will be skipped, and we are going to get just these 116 imports. While the imports are working, I'm going to enable the autocompletes. The autocompletes helps you in the Sparkle, and whenever in GraphDB there is a suggestion area for typing an IRI, to auto-suggest it with what you have currently in the repository. Okay, I'm building this. So I'm now going back to the OpenRefine interface, and I'm going just to create the project. I'm going to choose the file, and this is the CSV file which was downloaded. And this is the same file I was presenting. In this case, this is really the CSV file. So what you get here are a few different columns. One is the charter number. Basically, this is typically the ID which was used to identify this type of a bank, the bank name, the city, the state, and the RSSD column, which we really need in order to know how the Federal Reserve identified this bank. The interface is going to guess all the values and the structure of the data, so there we know anything what we have to do. I'm just going to create this project. and we have 848 rows. At least this is according to the Federal Reserve and the full number of the banks which are available. You see that this is close to 7 times more than what we have in the public sources. So one of the challenges here is that these are string values, and if you want to directly RDFize them, we will have really a hard time because these values will not match in any way with what we have in the knowledge graph. So the task here is really to see what is the quality of the data and later on clean it and integrate it. So the first thing what I usually do once I get any type of a CSV, Excel, or any type of a file is I'm going to do this type of a faceting, which is going to give me what is the distribution of the data. And what I can see is that there are some really duplicated values which becomes very clear and visible here. So this is the state of California, which has 24 times, 24 times it's mentioned, but we have also California, which in this case, although this is a public file, it has a space. So what I'm going just to do is I'm going to exclude all this data, and I'm going to clean up. There are some common transformations you can use to trim all the leading and spaces. So now the data looks much better. There are no duplicates, so the states are now much more consistent. The next thing to do is to see if for the cities how they are spelled, and we are going to use a different option in order to check them. So we are going to say I'm going to do a clustering in order to see if they are spelled properly. And what we can see, because this data is really submitted from the original authors, is since they don't use any identifiers, they can spell slightly different the different type of cities. So we see St. Louis here and McLean is 2 different spellings. For the Crystal Lake and Lake Crystal, I'm not sure if this is the same one, but let's, for the sake of the demo, let's say we are going to merge them all. So I'm going to merge, recluster, and now all the data is really clustered. So we have cleaned up all this data. The next step is really the data reconciliation process. Is we really want to link these to the different type of states. And I'm going to start this reconciliation process. In this case, I'm going to use GraphDB comes with the external reconciliation link towards Wikidata. So I'm going to choose it. And the reconciliation service is going to take the first 100 values, their strings. It's going to submit it now. It's really they're submitted to the remote service, and it's going to give us basic on statistics. What are the most common types which were found in this type of a column? So naturally, this is the state of United States, and this is the subject matter expert should know that these are states, not chemical elements, sovereign states, or something else. So we are going to choose the state of United States. And while this process works, it will take some time because this is a public service which has some limitations. But the process is that every row will be submitted, and the service will try, based on some heuristics, to tell us what is the correct identifier. This will take a few more seconds, but the objective here is that this part is we are going to get Wikidata's identifiers because we have gave some hints to the service that these are states, and we hope that this should be a relatively simple to guess task because there is no big complexity there to match the state based on these 2 letter abbreviations. So this process will take a while. And if you really want and you are interested, Ontotext is really a company which can develop specific reconciliation services which are much faster and more accurate than what is really publicly available. But in the GraphDB free, what we have included is only the publicly available reconciliation service which you can use. And now this is really the magic which happened. I don't say that it's a big magic, but the OH was mapped to the Ohio, and this is the Ohio state of America. The difference is that we have an identifier here. So if we click here, we are going to go to this entity, which is wikidata.org Ohio. And this goes for the other type of entities. And using these type of facets, we can see if everything was matched. And we see there are two matches which were not correctly identified. So what we have here is the city of Washington, and the state is really not known. At first, when I saw this example, I was thinking that there is a mistake in Wikidata, but it appears that I did a very quickly search that the District of Columbia is not actually a state. For some reason, the US government decided that this will be something different and it will be a special territory. So naturally, the DC is not a state, even if this file, it was put as a state there. And this is really where the semantics and the arguing of the subject matter expert starts, whether you have to decide, do I add this as a new entity? Because the system allows you to say, okay, this is not a direct current, basically. There are other types which match this. And in this case, I'm going to create this as a new state. But you can see, and we are going to see that this is a new match, and this is a state. Alternatively, you can try to guess and create new type of an entity, which includes all the states, and you say that the District of Columbia, DC, will be this type of states. It will have its own type, and this is how we are going to model it. So I'm not going to spend more time, but the process I'm going to just demonstrate the other steps is, for the sake of the time, is that you can try to reconcile also the cities. And for the cities, this time we can give as a hint not only what is the string of the city, but what is the state, which hopefully will make the disambiguation process much better, because we'll give some context. Find for something which has a label Lebanon, and then it's very closely related in the graph to the Ohio, but the Ohio is really a concrete node instance, which you know what is the IRI. So I'm not going to jump into this because this Wikidata service is rather slow and imprecise, but I hope you get the general idea what is really the tooling and how you can really map these things to things. So the next phase is really how we are going to make the RDF mapping, because this still is not an RDF data, it's still a refined model. So this is a new plugin which is part of the Refine. Everything is basically included in GraphDB free distribution and all other editions, of course, and allows you to quickly compose RDF formats and to compose the graph structure. So the very first thing what we are really going to say is that I'm going to say this is my, okay, I'll say this is the Federal Reserve.gov, and I'm going to say the base URI is resource. So from now on, everything which is really having just an IRI will use this base IRI. I can also define my own prefixes, and also some of the prefixes part of the repository and the model are also available for being autocomplete. So the first thing what I'm going to say is I'm going to drag the column charter number, and the interface asks me, okay, it will not ask me if this is an IRI because this is on a subject position, and naturally everything on subject position is an IRI. And it will say that I want to use as a source charter number. So the next thing what I want to do is to say this is an RDF type. I can write it right there. I don't have to really drag it or do it. Also, the interface is suggesting this type. And if I press enter, I can just say, okay, this is an RDF type. And in this case, I'm going to use the from FIBO, some sort of a entity. And in this case, I'm saying, okay, these are national bank, because I know that this file is a national bank. As you might see, I'm not going to use the DBpedia types because they are quite imprecise. They go somewhere very high in the FIBO hierarchy. So I'm using the precise meaning, which is a national bank, because all these banks are national. The next thing what I want to do is basically align this to a common schema. And in this case, I'm going to use the RDFS label. So this is the label of the bank. I'm going to type it as an RDFS label. The interface is going to suggest it and hint it. And in this case, I'm going to drag the name here. We need to do an extra step here because the interface is not sure what is my intention. If I want to make an IRI or this is a literal. And in this case, I'm going to use this as a literal because I know that this is the bank name and as a literal. Okay, so we have mapped these two type of columns. The next thing what I want to say is I want to say what is really the state here. And I'm going to see that there is a such predicate state in the repository, and I'm going just to drag the state here. So for the state, I'm going to use, okay, this is a value which was reconciled, and I can use the original value as a literal, but I can also switch to something more complex, which is the Graph extension, the Graph extension expression language story. And there is a very good documentation here, which is going to give you all details how you're going to work with this, how you do all these type of transformations, what is the model. I'm going to show very quickly what are the possibilities here. So in this case, we know that our objective is to get the IRI of the Wikidata. So I'm going to say that this is cell. It's going to give me some hints below, and I'm going to say, okay, I want to say cell, and these are actually the actual values here. If I type value, I'm going to see the actual values, which are the strings, but in this case, I want to use the IRI, so I'm going to say recon. This is the model. This is the best candidate because there is a scoring. If there are more complex scenarios, you may choose not the best one, but other reason. And I'm going to say DID. And for DID, these are the values which were reconciled on the previous step. Depending on the different service, the service can give you the full IRIs or only the local name. In the case of Wikidata reconciliation service, for some reason, the authors decided to return only the local names. But this is not a problem because here I can say, okay, I'm going to type https wikidata.org entity, sorry. Okay, this is really the WACF. And I'm going to put one more slash and say, okay, this is the actual value which will be matched to the graph. You see that this is an error-prone process, and if you don't get these type of hints, or it might be difficult to guess this. Okay. So, and the next thing, I'm going to use the IRI because the system does not know if this should be a literal or an IRI. The good thing here is that I can go and say I want to preview what were the mappings because I'm not sure if these mappings, how they will appear. And automatically this interface is going to take the first row and it's going to showcase how this will look like. And I can see that this is the base IRI. This base will be appended here. So this will become Federal Reserve Resource 8709110. I can extend this and say, okay, I'm going to put the bank namespace here. So this will automatically update everything. And we say we have a state here and the actual entity. The interface gives me also to do some more complex things. So if I want to include also this RSSD identifier. So I'm going to type my own predicate here. And I'm going to say, okay, I'm going to drag this here. And in this case, I'm going to use this literal. And what appears here is that we have the RSSD and this type of a literal here as a identifier. So I'm going to go in the other mode to see this very clearly, but we see that this is an IRI. And here what I want to do is to add a nested triple, which is going to precise this in a more correct way because this is an IRI. And I'm going to say this is an RDF type. And I'm going to use from FIBO that this is the full name, which is the Research Statistics Supervision, whatever is the full name of this type of identifier. And in addition, I can say here, I want to add another predicate for the same type of a nested value. In this case, I'm going to say the actual value is, I'm going to just type value, there is such a predicate somewhere, and I'm going drag and drop the data. Once you drag one time a column, you see that it appears great because this will give you the hint that it was already used. And in this case, I'm going to put it also as a literal in order to see this. Now I'm going to switch to the preview and we see what is the type of an RDF we have generated. This type of a mapping can be saved, so this will be preserved as part of the project. what you can do is to download the mapping or upload your own configuration if you have already did it, translate it, convert it to RTF. Basically, this will apply the full transformation to the file so we can download it. Or the alternative thing is to go and generate for me a Sparkle if I want to see the same type of data through Sparkle. So this is the same type of a mapping, but now the system is going to generate a mapping in Sparkle. It's not only the user interface, you can write down this type of mappings also with Sparkle. The construct part takes the type of a table we have just created. So you see that this is the state, the RSSD, and the different type of identifiers we have selected. The source is a virtual endpoint, which is basically this refine project. This is the refine project. And here the interface is going to automatically generate everything what we did, including it supports the Graph transformations also through Sparkle. So if you design for one time something, it will be also available in Graph. Another alternative way to use the same functionality, if we go command line, is to go here. I have prepared the same type of a mapping, so you can apply the same type of transformations using the same curl type of an operation. How this is going to work is you say this is the type of an endpoint, which you can check in our documentation. The only specific thing is that we need to identify the type of a separator, which is a comma. This was a hint, if you remember, which was given during the creation of the project. The other thing is a mapping JSON, which is the mapping which we have just created, and we can download it from the user interface. And the other file is really the National Bank CSV, which was the file we have used to import it. The service supports content negotiation, and I'm going to basically say I'm going to output this to an RDF file. Sorry, turtle file, because we say this, we want this in a turtle syntax, and we are going to download this and see as a turtle file how it appears. And we can open the turtle file, and you can see that this file was readily generated. So I'm going to move back to the presentation. I hope this demo was useful and you were able to trace it. What else to say? These are the different type of flows you can use the interface not only to make interactively the transformations, but also to script them. One of the things which is really important to say is that you have this type of a multiple flows, and if you go directly from the structure file to a mapping descriptor, we have skipped the data reconciliation step. So just to point you to this, if you see there, the state is missing here because we have skipped just in this type of step in the process, and because there were no reconciliation service. Basically, we have skipped the reconciliation service. There is also a client of the OpenRefine interface, which can really script all the types of transformations, including the reconciliations. I'm going just to show this because probably it's important to give you this disclaimer here. The refine interface, once we created this, is recording all the different type of operations. So I'm going just to open this once again, open the project. Okay, it appears that I have to click this. Okay, these are the risks of the wipe demo. Probably the service has gone. Okay, just to give you some benchmarking information, which is probably also important. On a standard computer with 20 gigabytes of RAM and 56 columns, basically these are pretty big files. This is the ability and the speed to do this transformation in this way. So if you have a file with 100,000 rows, the execution time, which is in minutes, please pay attention, will be like 0.9 minutes. So this is something like 1/5 of the minute or 12 seconds. And you see that the Sparkle transformation is a slightly slower one because it uses a different processing engine. So even for files up to 1 million, it's really a 1 to 2 minutes the overall transformation time. Okay, that was all my presentation. So let's just go and quickly see for some type of questions, if we have them. So one of them is really, what version of Ontorefined are you using? We are using the latest OpenRefine. Actually, the correct way is to say we integrate the OpenRefine and extend it, and that's why we call this Ontorefined. So OpenRefine is the original project, and Ontorefined is the OpenRefine with our extensions, which are also available. And the version is, if I'm not mistaken, is the latest one, which is 3.3. Okay, the next one is, will there be a support for RDF star? So RDF star is supported in the Sparkle transformation. If you go to the Sparkle view, you can generate also any type of embedded triples or triples types. And once you go to the Sparkle transformation, basically it's already supported. For the user interface, it's possible to extend it if there is interest. It's obviously a feature we can add into the next versions. The next question is, what drives the reconciliation service? Okay, so the reconciliation service is a standard. There is also a DAO3C group which is working how to standardize this process and to make exchange of the data. There are multiple reconciliation services which are publicly available, and your OpenRefine or Ontorefined interface can directly access. In this case, with the GraphDB, we are including only the Wikidata, but if you do a Google search, you're going to find many data sources which are exposing a reconciliation service, and you can do this. Typically, every service uses its own heuristics. The only thing which is common is the API and the interface, which allows you to give as hints some other metadata entities in order to improve the precision of the disambiguation process. Okay, let's see if there are some other questions. Is Ontorefined included in the free edition of GraphDB? Yes, actually what you're seeing is now GraphDB free edition. Oh, this was the demonstration of GraphDB free. And let's see if there is one more question. Okay, yes. Can generating RDF from Excel be recorded? Okay, I hope that actually this was the full idea of the diagram showing this, that there are two types of flows. One is the interactive and the other is the batch mode. So yes, it can be recorded once you go to the OpenRefine and you generate the mapping basically on a small fraction. You have two options. One is to really script the generation using OpenRefine, including the reconciliation process, and this is something which you can script via the OpenRefine interface. Or the other is to use the batch mode, which is going to do all the transformations. But as you might see, the reconciliation service, because this is an interactive process, happens only on the interactive flow. Okay, so if you have any further questions, don't hesitate to just go to GraphDB website, download it. GraphDB is absolutely free. We are a company which is responsible to the community, so you have really a very simple upgrade path for your business, starting with GraphDB free and later on go to standard and enterprise edition. And if you have any questions, you can always find us to the GraphDB support mail list. Thank you for your time, and I hope you enjoy the presentation.